Welcome to qnawire.
To assume the rope is moving without slipping, so the linear velocity would be equaling the angular velocity of the pulley times the radius, and so the angular momentum would be equal the angular momentum sub A plus the angular momentum sub B plus the angular momentum of the pulley. This would be equaling mass of A times V times R plus mass of B times V times R plus the moment of inertia times the angular velocity of the pulley. And so we can say that this would be equaling m sub A V R plus mass of B V R plus I times V over R. And we can then say that the angular momentum would be equaling the sum of the mass m sub A and m sub B times R plus I over R multiplied by V. This would be your answer for part A. For part B now, the net torque about the axis of the pulley is provided by gravity. And so we're going to be using equation 11.9 in order to find the linear acceleration. So we can say that the sum of torques is equaling the derivative of the angular momentum with respect to time. And so we can say m sub B G R equaling the derivative with respect to time of the answer we found in part A. And so we can say here that really the derivative with respect to time, because all of this would be considered a constant, we would only be taking the derivative of the velocity with respect to time, and that's simply the acceleration. So we can say that then m sub B G R would be equal to the acceleration times, again, mass sub A plus mass sub B times R plus the moment of inertia over R. And so finding the acceleration, this would simply be equaling m sub B G R, and then this would be divided by the sum of the masses times R plus I over R. And simplifying, we find that the acceleration is going to be equaling m sub B G divided by the sum of the masses, m sub A plus m sub B, and then plus I over R squared. This will equal A, and this is our answer for part B. That is the end of the solution. Thank you for watching.